The subject name is software engineering. So in this subject, what we are going to learn is given in the form of a syllabus, and we are just going through the syllabus now. So the syllabus consists of 6 modules. Module 1 is about process model, and here when you go through it, there are a lot of model types are given, because in software engineering, any one process model you can choose for your project. You can apply and make it as a role model, and based on its process, you are just going to implement the entire project, or you can customize the project based on these kind of any one of the process model. Here comes the latest software process models also included, because industries are following agile process model, and hence this kind of an agile process model is also you're going to learn in this module 1. As well as there is a project management tool called Jira. With the help of it, the entire software can be managed. So that also we are going to learn in module 1. In module 2 onwards, one by one phase which involves in a software project development is going to be discussed. So module 2 is about the first phase called understanding the requirements. So inside it we are going to learn draw different diagrams. Those diagrams are called as UML diagrams. So here comes we are going to learn different way of the diagrammatic perspective of software representation, and how to prepare an SRS document, software requirement specification document, because once it is analyzed, once it is discussed, the requirements are confirmed, so we'll go for a documentation. So based on this documentation report only, one by one step which are involved in this particular project, we are going to learn. So that is why this SRS, how to prepare, that also we are going to learn under the topic understanding requirements. So module 2 is about the first phase of a software project, and how to prepare the SRS document, how to draw different diagrams. With the help of it, how can you represent the overall a view of the particular project. So with the help of it, when you get a blueprint, you can analyze the entire scenario or the entire objects which are involved in the particular project. Module 3 is about the second phase, that is called designing phase. So here comes yeah, what are the different architectural styles and pattern that you're going to follow in your software project implementation, how you are going to design each and every component or the interfaces which involves in the particular project. So that is about module 3, and module 4 is about testing part. So but here in this subject, we are not going to learn any coding part. So we are just going to do the analysis part, and based on analysis, once it is done, actual developers will do the coding part, and then they will go for testing. So here comes, there are a lot of testing types are there, and the base and here we are going to learn the testing tool called Selenium, and with the help of Selenium, how you can perform software testing within web application. We are going to demonstrate, and we are going to learn about it. But at the outside view, when you just consider testing is categorized into white box and black box. So black box which gives the external view, white box which gives the internal view, and one by one code, one by one line we are going to do testing. So how to write a different type of test cases, how you can execute these test cases over your project. So that we are going to learn in module 4. That is the next phase of software development. And at last, in module 5, we are just going to analyze the quality of a particular project as per different quality standard. We are comparing the designed product with the quality standard. Once it is confirmed and meet all the requirements, then the project is going to be deployed to the client end. And once it is deployed, sometimes the client may come for some modification. So that is called software configuration management. That's the next phase. So after maintenance, when people come for modification, addition or removal of modules, or any modifications in the overall project phases, so those baselines are going to be, the base configurations are going to be identified, and once it is approved, again the project will go for the next version of change or a release. after that. So we are just going to measure those kind of software against certain quality metrics, and we are going to evaluate it. So all those things we are going to learn under the module 5. Module 6 is about agile AI, since the subject is software engineering with AI. So here the module 6, which integrates the concept of how AI can be integrated so that the development of a software can be faster, and how it can be delivered with optimal code and other purposes. So these are the overall structure of this particular subject. So module 1, module 2 and module 3, like that module 6 are there, which explains each and every phase which involved in this particular project development. And there are two texts we are going to follow. The first one is Roger Pressman, and the second one is Carlo. And this is for the last module, that is Agile AI, and most of the modules will be covered by the first textbook. Now we are going to learn about the introduction of this particular subject. So from the name itself, what is software and what is engineering? These two are very, very important, right? So what does mean by software? So software means a collection of programs are there and which are going to be integrated and which is going to perform its function or the operations, what is given by the customer. So there are a lot of softwares are there, and we all have already studied about. So what are the different categories of software, like system software and application softwares are there, and system software which can able to manage the overall functionality of the particular system. So all operating system based softwares which falls under the category of system software, as well as compiler, loader, assembler, linker. So when you work on developing such kind of software as a developer, when you involve in such kind of development of code, then you are called as a system software engineer, maybe. And application software, so which runs on the system software. Lot of Android applications also there, as well as system based, web based applications are also there, standalone applications also there. So like this, there are other application softwares are there. And so this application software which depends upon the system software. So once the system software is ready, which can able to manage and support this application software. So this is how software is classified into system software and application software. And in this subject, mainly we are going to learn and discuss the ideas and the concepts which behinds the application software designing. So as you all know, what is meant by engineering? Okay, so you are going to apply all the scientific knowledge that you have learned to make it practical, and with the help of developing some, with the help of some frameworks, you're going to improve the process, or maybe improve the design, improve the code, or improve the entire scenario which involves in the software development. So that is why you're going to apply the entire scientific knowledge or a practical knowledge to build such kind of a software. So that's why this subject we are learning software engineering. um, and this is a piece of information, like what is program and what is a software. So there is a difference between program and software, right? So so a program means a small code while you write. A file is called maybe a code when you put it inside a file. When it works, that is called as a program. Likewise, small programs that you have built, and finally when you connect all these programs, when you run it together, then it is called as a software, and or an application. So when you run, so we are calling that. Okay, so every program while you write, it consists of set of operating procedures or manipulation codes. Logic will be there, and at last you will do the documentation. So program, documentation, and all these operating procedures are together called as software. So program means which consists of some subset of or a small piece of code which is written or stored in the form of a file, that is called program. And collection of programs are put together, and when it works, that is called as a software. So that is why software is more than a program, more than one program, that is called as a software. And again, some more the inside that figure, what is program? It's a code. And what is documentation? So every documentation or a project report which consists of some flow chart or some ER diagram, which represent how the application works and what is the behavior of the entire application. So that talks about in the part of documentation. And what is operating procedure? For example, if you want to run the application, what is the basic requirement, which software and which frameworks and which database are supposed to be there. In case of any failure, what input only it can able to process, or how to restart this application. So all kind of informations will be available inside this procedure. That is, when you write a function, all these kind of set of codes will be there. So all these are called as so when you put everything together, that is called as a software. Software engineering, we are learning why software engineering. Without learning software engineering, also people are developing software at present. Maybe you also have experienced many project development, but after learning the subject, you may develop it in a different way. So that is why a professional way of developing the software with the help of learning software engineering. So it is an engineering discipline, and through which there are some well-defined principles and techniques and procedures are there. And as per its order, when you deal with design or when you work with your team or testing, so this principles you will apply in a professional way. And so that is why the software is reliable and more effective, and it is going to be useful for your customers for a long time, and it can survive in the market for a long because some of the applications, for example mobile application, when you consider in Google Play Store, there are some of the mobile applications are we are using in a day-to-day life, and some applications may be hosted by different developers but may not be useful for all the people. So applications should support the present as well as the future. And so in such a way, when a software designer or a software engineer develops such kind of application with all these kind of forecasting information inside the particular software, then only it will be useful for all the users. So why software engineering? With the help of it, you can able to manage a large software. For example, if you have idea on software engineering, then you can able to work with Flipkart, Amazon based a large application, or a Facebook social network pages when you develop. Okay, so it will be easy for you to manage. So dashboards from different user perspective you can create, and you can maintain transparency at the other end. The people who created this big project may be more beneficial with the help of this kind of software designs. So you can able to manage a large software with the help of learning software engineering for more scalability, so more number of users and different type of platforms where different computer terminals they may use for accessing. So everywhere your application is compatible, and it is going to be a platform independent, so reliable, likewise cost management, cost effective, and you can manage the dynamic nature of a software. For example, software evolves over a time. Today we need a certain interface with certain features in tomorrow, and tomorrow we may integrate certain other features. For example, in the beginning maybe a part the role of a was very little, and at present the role of a is improved. So algorithms and dynamic nature of the application changes can be incorporated with the help of learning this software engineering, and better quality management as well. So that is why you have to learn software engineering. What are the characteristics of a good software engineer? So you must have all these characteristics. Yeah, exposure to systematic methods. So any problem, any feature, when you design, you have to apply the systematic methods, what you learned. And familiarity with software engineering principles and terms. Sometimes your development team or a manager may say certain terms to be included in your project. Maybe follow agile or follow Kanban. Which method you have to adapt for? It's a culture, and so you should be familiar with all the software engineering principles, because Accenture is following this kind of agile process in their project development. And even when you consider IBM, they are following Kanban method. So you should know what is inside this agile process. So you should know familiar with this kind of principles of agile. So you must have a deeper knowledge on Agile. You must have a deeper knowledge on Kanban. Then only you can apply in your project or a small project or a small phase of development when you do it. So good technical knowledge of the project. Definitely you must have good or a sound technical knowledge, because every software engineer, when they start involving in developing a software, they must have knowledge about that particular domain. If you are involving in developing a medical application, so thoroughly you should have an idea about the entire medical problem statement which is given. For example, you should know what is cancer, what is not a cancer case, and what are the different modalities are there, imaging techniques are there, and how to analyze each and every imaging technique. As so you must be equivalent to a doctor, so you must have all the knowledge of the doctor, then only you can write code and with the help of it you can support. If you are working with insurance domain, for example, just you are developing a web application dynamically and managing the features of an insurance based application. I'll show you some sample websites of insurance, then only you will know it's not like a simple website designer design based experience. So you must have a sound technical knowledge of insurance domain, then only you can able to handle different code while you write and implement. So good programming ability, good communication skills, this is very very important, because then only you can able to extract information from the actual users who are going to use the application. And high motivation, definitely it is needed. Sound knowledge of fundamentals of computer science, intelligence, ability to work in a team, because most of the software project development is a team-based projects, because it consists of lot of modules. Every software which consists of lot of modules, so modules are going to be distributed among different users, different teams, and you have to, so you must have all these skill set. So far whatever we have learned is about what is software engineering, what is software, what is program, and what are the different characteristics of a software engineer. And what are the other things which are important in software engineering? So when you look at this one, you have to you're going to handle a big project. So while you develop such kind of a big project, you have to minimize the software cost, and you have to reduce the complexity, and you have to reduce the time in development. But at the end, the application must be reliable and effective. So 24/7, the application should support and handle any kind of issues or any kind of help or access or operations which are to be performed by the user. So, as a software engineer, you must consider all these important features when you develop an application. Now we are going to enter into the core part of the syllabus. So the first main term you must know, that is called software processes. So what is meant by software process? So everybody is supposed to go through a process, or every product must go through, or every material must go through. Then only it will be a final product with high quality. For example, as a student, you must go through n number of tests, n number of practices, then only final degree is going to be awarded. Similarly, software also. The software also must go through a set of process. So every process will be every process consists of set of activities, and finally everything is connected with the outcome of the final software product. So here comes one team may be completed, or one person in a team may complete a particular work that will be given to the another person. So he must understand, and then he must fine tune whatever is required, and finally they have to roll out the final application for integration. So this is how a software process is going to be. So what is meant by software process? It's a set of activities and finally an associated outcome that will produce the final software product. So software will go through series of steps of or a sequence of processes. Finally, the final outcome is called as a software product. So initially it is supposed to go through different activities. So that is called software project. Finally, the end result is going to be called as software product. What are the four key phase processes which are involved in this kind of a software process? So mainly specifications and development, validation and evolution. So the first activity which is about its specification. So here comes you're going to identify the functionality of the particular project. So that means what this project is. For example, consider a digital watch. You're just developing a digital watch or a timer in your application. So what is the purpose of the or the functionality of this particular software is it must show time. For example, in your software interface at the bottom, here come you can able to see the timer is running. The timer is, what is the functionality of the timer? The timer must show the time. So that is called the main functionality. And what is meant by non-functional features of this particular timer? The font size. Maybe time is important, that is functionality. Other than that, color, font, size. So all those things are called as a non-functional features. So likewise, every software you have to identify its functional features and its non-functional features. And while you start development, the developed product or each and every phase must meet the requirements what is already given. So as per the requirements, you have to confirm. For example, um, in big data applications, while you do analyze a particular data, there are some sequence of steps will be there. When you analyze one step, another step, finally the data will be fine-tuned and you will get the final outcome of the data will be more clean and it will be useful and efficient when you remove unnecessary part of it. So likewise, software also, you have to cross verify with the requirements what is given, and as per the requirement, if it is done, one by one requirements are completed, so the software is developed. And then you have to validate. So as I have told, you have to evaluate with the customer's requirement. For example, the customer want a small train which should run. So you have, for example, with the help of an IoT device and components, you are making this small train. And what's the functionality of the train is it must run and it must go through the particular track. Through the track it is supposed to go through properly, and finally it should come back to the point. Where you start, it should start, and where you stop, it is supposed to stop. So this is how you have to evaluate. When you press the start button, it should start from which location it is stopped. Where you want to run through it or you want to stop it, okay, pressing different button and you have to evaluate. So that is called software evolution. So sorry, this is called software validation. Press buttons and check its functionality. So that is validation. Evolution, okay, so meet changing client needs. Suppose the client is saying like, okay, I don't want the train run from right to left. I want, okay, in the opposite direction. If you change that also in your application, if it's run, okay, so that means the customer requirements are satisfied. So this is how you have to check any software that you have developed when you deploy it along with any hardware application or with any the software may be a complete software and it doesn't depend upon any other hardware. So you have to give a number of inputs and you have to check. So that is validation, and finally overall requirements are met. That is called software evolution. So software evolve. So any any changes are given, for that also the software should behave well or function well. So that is called software evolution. So all these are the 4 key process activities that involves in software development. What is meant by software process model? So SPM, in short form we used to say SPM. Okay. So as you can see, it's a spinning mill, and where the cloths are stitched and moving through one by one layer. Yeah, so one phase is finished, then it is moving to the next phase, and finally it will be completed once the stitch and everything is done. Quality check will be done, and finally it will be ready for dispatch. So similarly, software process also. So software will go through different mechanisms of development, and finally it is going to be a fine-tuned activity, and that is ready for deployment. So mechanism of dividing software development work into a distinct phases to improve the design, product development and project management. So this is called as software development life cycle. But in more we are going to learn about the software development life cycle. Um, so here comes the workflow of the model is supposed to be designed, right? So what is the input, what is the process, and what is the output, and its dependencies also. It should go through track 1, track 2, track 3, and finally, okay, it should reach. When you go through the track 1, what are the processes are supposed to be completed? When it go through the track 2, what are the processes supposed to be completed? That is called as a workflow model. So all these are activities which are performed by the human beings only, right? So that is the workflow model. What is data flow or activity model? So set of activities will be there, and here comes some transformations. As I have told, data will be go through one phase to another phase, or a different process. Says at the time it is supposed to be cleaned and fine-tuned. Finally the data will be straight away useful for performing certain kind of operations, right? And what is the role or action model in this software designing part? So, but there are different people who are involving. In the previous video we have seen, there are a lot of people are involving, and each people know their assigned work, and they know the process they are supposed to do it, or the activity is supposed to be performed. So they are responsible for such kind of roles. So a software process model also, which consists of these kind of different models inside this set of activities. What is meant by software development life cycle? As a human, we have started our life from infant, and now we are in adult stage. So one by one stage when we go, and our knowledge level is updated, and will be a perfect man or a woman at the end, all right? So this is how software also must go through one by one phase, one by one step, and finally it is going to be a fine-tuned software. So it is a step-by-step approach to develop a successful software. So what are the different phases involved in this software development life cycle? So it is it's a routine cycle, so that is why it is given in circle phase. So it is going to be repeated again. It's an iterative process. So what are the different phases involved in software development life cycle? So it starts from here, that is planning and designing, implementation, the next testing and deployment and maintenance. So these are the 6 phases which involved in software development life cycle. So what is the first phase? Planning phase. And what are the things we have to do it? One by one step we are going to discuss now. So as per planning and requirement analysis phase, so every project must be completed within the planned duration. So a chart will be prepared. For example, we have academic calendar. As per the academic calendar, what is supposed to be completed today? For example, consider today is day 1. So day 1, what I have to do? So day 1, I have to learn in this particular subject some at least 0.1 percentage I have to learn, or okay, in this particular subject maybe I have to complete as per this particular day 1 lab experiment, 2 labs experiment. So likewise we have a schedule, so only we can able to meet up the lab requirements as well as the class requirements, and we are able to ready to face the exam on time. So similarly, project also will have a calendar. So this calendar is called per chart. Okay, so per chart or timeline chart or Gantt chart. So there are different charts are there. For example, our calendar is called as academic calendar, right? So similarly, some other colleges they may name it in different way. So which consists of schedule. So here also this per chart or a Gantt chart or a timeline chart consists of schedule. On a particular day, okay, consider here there are list of activities are scheduled, and in this, for example, our subject module 1, at least one topic we have to study today. So as per this project phase, today they have to complete module 1, maybe part 1 is supposed to be completed. What next? What next? Sometimes parallel cases also. We may start learning module 1, one topic, and I may go through module 2, some second or third topic which may be relevant to first topic. So I can merge these two and I can complete parallelly, right? So this is how they will also identify each and every phase or the scenario which involves in the particular project. So on a particular room, everybody will be assembled and they'll start discussing when a project comes. So when a project comes, they will they'll discuss the project scenario. The scenario consists of user stories. So whatever user story told by the customer will be analyzed by the business analyst, and they will listed out these are the stories. Point number 1 they have told, point number 2 they have discussed likewise. From that, okay, they will align and pick the stories and they'll load it into the software project management tool, and they'll start collecting the requirements related to the particular story for implementation. So in the first phase of analysis part, you have to define and prototype the system requirements. So you have to collect all the requirements related to the particular project. Maybe you're not clear about certain processes. Maybe you're not clear about certain data or some functionalities or some analysis parts, some user roles. So you have to go for multiple discussions with the customers, and you have to sit and you have to analyze. So this is mostly done by the business analysis. So they'll go for n number of meetings and they'll record every meeting informations, and that will be available for the entire team development. Team leader may have such kind of video recordings or audio recordings. They'll play repeatedly to know and understand the requirements. So this is called define the prototype of these system requirements. Evaluate alternative to existing prototypes. Sometimes the company already had certain kind of projects which are already available and they are just going for modification. So you have to go through the previous requirements and what else is to be added now, that you have that alone you have to collect it now. Perform research analysis to determine the needs of end users. Sometimes you may go and interact with the real users who are using that application. You have to collect their feedback, what else they need, what else is included may improve the business processes. So you have to collect and you have to include. So all these are called as planning and requirement analysis phase. The next phase of the project is designing. So we used to do it by the help of paper design first. It saves our time and energy and as well as material. For example, maybe it is a big application. We used to take a big chart and we'll divide small portion of it and we'll draw the component or the interface how it is supposed to be. At present, there are industries, they are following the same kind of model. So they'll put the design while they discuss with the customer, and then the paper is going to be scanned with the help of a software, and it is actually going to be converted into an interface. So the interface may be a static interface at the time, but it is easy. In one stretch discussion itself, you can finalize this interface design part. So user interfaces, system interfaces, network requirements, databases, all this designing is important because database is also consists of design. So you have to design the front end as well as the back end. So the front end designs are user interface design, which consist of text box, option button, drop down list box, buttons, tabs, dialog boxes, corners, some of the menus, submenus, likewise all the components may be there, and icons, meta designs. So all those things you have to keep it. Sometimes maps, locations, any other apps are supposed to be integrated inside your application. So the entire interface design is supposed to be planned well in the beginning itself. Then only you're going to write the code for making it work. So it is supposed to be an functional one. So here you're going to draw the paper design, and then you're going to convert that into a system design, and scan these paper design, automatically it may be converted into an system design. So every small interfaces from the perspective of the user, administrator, different roles. For example, in a Ediserve application, while you log in as a user of student, your interface design is different. As a faculty, my interface design is different. As a HOD, their interface designs are different, and their interactions and functionalities are going to be different. So you have to design interfaces in all the user perspectives. So you have to identify first of all the hierarchy of different users, and then their interfaces, how it is supposed to be designed, and the corresponding code is supposed to be written, supposed to be finalized in during the designing phase. So this is called designing phase. The network requirement for maybe what about your server and storage, how many clients, how many server, and what about the backup data is supposed to be taken, what about the code for backup, and which are the from okay, when an application is working from an browser, do you want to lock the browser icons or browser options? So whether application is implemented in an internet or an intranet, or what type of network you want to include it for your application, and what about the collision handling techniques, how you're going to answer different customers at the same time. Okay, so deadlock, starvation, all the requirements are supposed to be analyzed in the beginning. And about the databases, so different levels of users are there. So duplicate redundant data supposed to be removed. So apply the concept of normalization, based on that you design the tables. So you have to draw the design and the table requirements based on ER design, and finalize the front end as well as the back end designs in the designing phase. The next phase is implementation. Actual code you have to write, and as per the specifications given in the document. For example, in a particular drop down, numbers are supposed to be from 1 to 10. So that 1 to 10 alone supposed to be there. It is not supposed to be more than that. Some fractional units are supposed to be selected by the user on different units. It's supposed to be updated. So follow all the requirements. Based on that, you just code and develop the entire app. Consider in a banking application, every paisa is important, right? If there is a small amount of variation is omitted or included, that will be a big problem. So you have to test all those things. You cannot go back, right? So similarly, if it is a medical cases, also it is very sensitive. Even if there is a chances for tumor, early detection, so you must handle all the sensitive informations, and the machine should predict, the system should analyze carefully. And if it is an avionics based software also, there you cannot avoid errors. So you have to minimize all the errors, and you have to keep it in zero. And when it is given and tested at the other end, the end user end, so the defects are supposed to be zero, right? When they have identified even if a small defect, okay, the causes are going to be huge. So testing is important. All type of testing you have to thoroughly incorporate it inside your application, and you have to test all those things. Finally, once it is ready, your application is going to be deployed in the customer end. You have to go and train the customers. Sometimes the person who is going to use or the platform which is developed for them, you have to give them enough instructions and trainings, and you have to provide. Even if it is a medical doctor, you have designed an application for a medical doctor, you have to help them for a long time, and you have to you have to identify every now and then and collect the feedback for any changes which are required from their end. Finally, maintenance phase. Sometimes we may think every bugs are closed, every loopholes are closed, but always software will have a small bug. Okay, some loopholes are say, so it will come for modification. So you should be in touch with the final team who are actually using the project, and you have to help them every now and then for any suggestions or based on the targeting market. If there is any changes are needed, you have to incorporate those kind of changes, and you have to support them for a long time. See here, there is an application which is designed, which is playing with the human being and intelligent enough. Here also it's a hardware, and inside the hardware there is a software, and with the camera input it can able to sense, and the hands are going to operate as per the instructions given. But at the same time, it is going to be wise enough and intelligent enough in playing with human beings. So this application is also, it's a hardware, but inside that there is a software which can able to manage the overall application. And finally, it can able to monitor, play, control everything, right? So this is how, while you design any software or a hardware application, you have to consider all the different phases which involves in this particular kind of development. So that involves software development life cycle. So software development life cycle covers all these phases for successful implementation of this particular software. Next, what is umbrella activity? So when you put together all these things, that is called as umbrella activity. So a series of steps or procedures followed by the software development team to maintain the progress, quality, changes, and risk of the complete development task. So everything which comes in one single umbrella, but you have to consider whatever I have told, no, all those things are collectively called as umbrella activities. So in an umbrella activities, what are things you have to consider? For example, here there is a concept called risk management. So risk, some of the risk can be monitored, and it can be planned, it can be identified yearly. And so some risk cannot be predicted yearly. When it comes or when it occurs, it is supposed to be handled. There are a lot of weather forecasting applications are there which can able to forecast at a at some percentage, but once the risk is occurred also, it is supposed to continuously report those kind of risk. And so that is why we used to say proactive risk and reactive risk. So proactive yearly identification and monitoring and control, and reactive risk, once it is occurred, do you have a code to handle it? For example, once upon a time we had a problem with Facebook, and WhatsApp also stopped for a second or a few hours. So because of that, they have come to that, from the profit ranges, the companies pushed back. So so it's pulled down, right? So this is how, because the code was missing to handle certain risk. So that is why, so you must have a risk handling code in your particular project as well. So your software project tracking and control, formal technical reviews, software quality assurance, software configuration management, document preparation and production, reusability management, measurement and metrics, risk management. All these are comes under the umbrella activities. So any software, you must have answer for all these. You must incorporate all these inside your development phases, so that you can be a successful, your product will be a successful product in the market, and people will trust and started using your application for a long time. So all these are called as umbrella activities.